Hi, math lovers. Welcome to our review of 5.3 to 5.5, Fun with Logs. We're going to review sections 5 through to 5.5. If you have not done these problems yet, you should do them. All right. Stop the video. Don't just watch my show. Take out your paper, your work. Let's find out where you made mistakes, where you got things right, where you got things wrong. Okay. So I'm going to go through this nice and slowly. This is the kind of video that you can fast forward if you need to. You can go to problems that you need to review. So I will not feel badly if you do speed up through problems that you got correct. Okay, so going nice and slowly, I'm staring at question number 1, and I see that I have a logarithm on all sides. I'm thinking my law of logs. How can I condense this with my law of logs? So I'm going to take this, I'm going to write the left side together, which is log of 2x squared minus 6 over 7 equals the log of 2. Straight up, it's log of this equals log of that. So the logs will fall out, and I'm left with 2x squared minus 6 over 7 equals 2. So I've got 2x squared minus 6 equals 14. Bring that 6 on over, and I've got 2x squared is equal to 20. Divide everything through by your 2. So I have x squared is equal to 10. Therefore, x is equal to plus or minus the square root of 10. Hopefully you got that one right. Taking a look at number 2. I see I've got a 5 on the outside and I've got the minus 2 here. Let's bring that minus 2 on over. So I've got 5x. Notice the x is raised to the 1/3. Only the x is raised to the negative 1/3, okay? Is equal to, if I bring that 2 over, I have, 20? Divide by 5. So x to the negative 1/3 is equal to 4. To get rid of that negative 1/3, I want to raise both sides to the reciprocal power. So x to the negative 1/3, raise this side to the negative 1/3, raise this side to the negative 1/3. And so I have x is equal to 1 over 64. Okay, nice fun problem there. All right, number 3, scrolling up. Solve each equation. Again, I'm doing some solving. Let's see here. Again, law of logs. This looks like the exact same question that I did earlier. Oops, sorry. Natural log of 4x squared minus 6 times 3, of course, is equal to the natural log of 30. I'm going to go ahead and drop the logs from both sides. So I have 4x squared minus 6 times 3, which is, of course, 12x squared minus 18 equals 30. Again, same kind of easy peasy. Add the 18 to both sides. So I have 48. Divide by 12, x squared is equal to 4. And therefore x is equal to plus or minus 2, plus or minus 2, okay? Number 4, I've got the 1/2 on the outside, so I'm going to be really careful of that. I'm thinking that if I take this and I bring it on over to the other side, it would be much neater. So I have 1/2 is equal to the log base 16 of x plus log base 16 of x minus 3. Okay, so oops, I'm so sorry about that. I got to move me. I'm in the wrong spot. There we go. Now you can see the whole problem. Okay, so this is going to be 1/2 is equal to the log base 16 of x. I'm going to go ahead and multiply, you guys. You know, this is the end of the chapter. Hopefully you're really good with this. So now let's use our bacon and eggs. So it'll be 16 to the 1/2 power is equal to x squared minus 3x. So 4 is equal to x squared minus 3x. Let's bring the 4 on over. So I have 0 is equal to x squared minus 3x minus 4. Go ahead, you're going to factor x minus 4, x plus 1, of course, equals 0. So I've come up with 2 answers. X is equal to 4 and x is equal to negative 1. I'm going to take those answers. I'm going to plug them back in to see if they're good. Are they good answers? Straight up, I'm thinking this x minus 1 is not going to be good, because if I take that and I put it back in the original, I'm going to have log base 16 of negative 4, and you cannot take the log of a negative number. So that straight away does not work. Let's take the 4, put that back in. 4 minus 3 is 1. Log base 16 of 1. Yeah, that's going to work. That's going to be 0. Okay, so that's a good problem. All right, moving straight along. Okay. I've got number 5. Okay, now you've seen this problem before. This was an exact homework. Move me around a little bit there. This was an exact homework problem, okay? Exact. I'm going to divide everything through here by 5. So that's going to be e to the 2x minus 4e squared. I'm going to bring the 5 over, 15 over, divide that by 5. That's plus 3 is equal to 0. I think this was what the problem was in your book. All right, so I'm thinking I could factor that. So that's going to be e to the x equals 0. To get 3, let's use 3 and 1. They're both signs are negative. Therefore, it's going to give me a positive at the end. So I have e to the x is equal to 3, or e to the x is equal to 1. So e to what power is going to give me 1? I know that's going to be x is equal to 0. That's a good answer. And then here, this will be the natural log of 3 is equal to x. And you can leave your answer like that for me, natural log of 3, totally fine. Or if you want to go and you pop it into your handy dandy, I think it's 1.10, which is equal to x. So, but whatever, either is fine with me. Okay, moving along. Number 6, 7, 8, and 9, I have some formulas. First is the compound interest formula. The second one is the half-life formula. And the third one is continuous interest. I need to make sure that I use the proper equation for what I'm figuring out. So the first one says, how long must you invest $1,100 at 6% compounded quarterly to yield $1,600? All right, so $1,600 is what I'm going to have at the end. Again, I'm going to show my reader I know my formula. This is the formula I'm going to use. All right, I'm always going to start with the formula to start. So I've got 1,600. I invested 1,100, and it's 1 plus my rate is 6%, which is 0.06 over n. Now it's compounded quarterly. That's 4 times a year. So I'm going to plug in my 4, raise that to a power of nt. So let's see, it's 4 times a year, and I don't know how long. So that's my unknown. This is the whole reason we're learning logarithms in this chapter, is because of the variable in the unknown in the exponent spot. All right, let's divide both sides by 1,100. So I have 1.45 repeating is equal to, I pop this into my handy dandy, and I get 1.015 raised to the 4t. Okay, so let's rewrite this using a logarithm. I would say the log, and my base is 1.015. Log base 5 of, so this is bacon and eggs, right? And my answer is 1.45 equals 4t. Right away, I'm going to divide everything through by 4. And this is everything I'm going to put into my calculator, all right? Do not leave your answer like this. Let's get an actual answer. Nobody's going to walk into the bank and say, how long do I have to leave my money in to get this amount for yield? Nobody does that. They want to know it in terms of years. So I go ahead, I pop this all into my handy dandy using my log base button, and I get 6.29 for t. And of course, that is in terms of years. Okay, that is in terms of years. All right. Next one, a tractor that 4 years ago cost $9,500 is now only worth $3,200. Find the annual rate of depreciation. Depreciation means it's going down. So instead of using that formula for my compound interest, so it'd be 1, I'm going to say 1 minus r over n to the nt. Now it says nothing about compounding, nothing. So I'm going to assume that n is equal to 1 here. It's going to make my life much simpler. So I'm starting out with something that's $9,500. So it's 1 minus, and the n is 1, so we'll say r to the power of 4 years. I know what my time is. Oh, this is easy peasy. So it's now worth $3,200. Divide both sides by 9,500, and I have 32 over 95. I'm gonna swing a little differently this time. I'm gonna go with my fraction. Okay. All right, so now I'm ready to write this. I'm not going to use a logarithm. I'm just going to use a reciprocal power of 4. So if I take 32 over 95, and in my calculator, I raise that to the 1/4 power, I'm going to have 1 minus r. Before I pop that into the calculator, if I'm solving for r, I could say r is equal to 1 minus 32 over 95 raised to the 1/4 power. And so that comes out to 0.238. So I'm saying it's going down by, if I want a percentage, that'll be 23.8%. All right, beautiful, beautiful job. Oh, I did it again. I should just get rid of my little video there. Get rid of my little self. All right, moving on. All right, so we got some money in this one and half-life. All right, so let's see. Half-life, I'm gonna use that half-life formula that I gave you. Okay, so we're gonna say our amount of what we have and sub-zero times my half-life and time over h. So it says here the radon has approximately 3.5 days for half-life. You currently have 500 sample. How long until only 2 are left? So 2 is the amount. I'm starting with 5. I have 1/2. I'm going to tell you what, I do not like to write the fraction. I like to write 0.5. So it's just cleaner, just cleaner. So T over my half-life of 3.5. Okay. We're going to divide both sides here by, oh wait, sorry, 500, right? It's 500, not 5. Be a big difference. So I've got, I divide everything by 500. So I've got 0.004 is equal to 0.5 raised to the power of T over 3.5. I'm going to go ahead and write that as a logarithm. So I will say log, and my base is 0.5 of 0.004 is equal to T over 3.5. Right, those are glued together with division. The opposite of division is multiplication. So if you feel like it, you can just say 3.5 times the logarithm of 0.5, and then my answer, right, is equal to T, and you come up with 27.8 days for your final answer. Okay, fun problem. Let's see, Julie, she's got some money in an account. She's got $8,500 in an account that pays 4.5% interest compounded continuously. Right away, I see continuous interest. A is equal to P-E-R-T, all right? Continuous interest, how long for her money to triple? Does it really matter how much money Julie is starting with? She's got $8,500. You know, if you want, you could say that she had, if you want to do 8,500, because, you know, you're a purist, 4.5 to the power of T equals 3 times 8,500. You know, you could write that whole thing out, but I got to tell you, I think 3 is equal to e to the 0.045 T power is so much easier. I'm going to write that. Now, if you want to do it, you could say log base E of 3 equals 0.045 T. Nobody does that. We say the natural log of 3. Let's just divide 0.045 equals T, and therefore I get T is approximately equal to, oh gosh, I don't have an answer here. Hold on, let me grab my handy dandy. My handwriting is so scribbly on my paper, I can't say it. Natural log of 3 divided by 0.045, and that's going to give me 24.41. Okay, so it's approximately 24. It's what, years? Okay, so years. Okay, good problem. Good problem. All right, number 10. This is your law of logs. Condense this into a single logarithm. Remember, division is the same thing in exponents as I'm sorry, said it wrong. Subtraction is the same thing as division. So I'm going to take with my 15 and my 5. I'm going to start by swirling them to my base. So I've got log base 9 of x to the 15th power minus log base 9 of y to the 5th power. I can write this as a single logarithm. Do you see it says the word single logarithm? So if you wrote it with more than one log in there, not right. Okay, you're writing it as a single logarithm. Beautiful, beautiful. Moving on. All right, another one. Expand this one. Now we're going opposite. We're using our law of logs to expand this. Notice that it's got time sign in between. So I'm going to write this as log base 9 of u plus log base 9 of v plus log base 9 of w, and it's to the 5th power. But before I put that 5th power right there, can I swirl it right there to the front? Right? Oops. Okay, beautiful. iPad, pencil. All right, so I've got, oh, that's so sloppy. Log base 9 of u plus log base 9 of v plus 5 times the log base 9 of W. All right, so you can write it that way. Then we've got my fun ones here at the end. I've got 2 fun ones and we're almost done. I'm staring at these, and before I even get started, there are 2 laws of logs that are not included, 2 values that are not given. Here my base is 4, so I would say log base 4 of 4 is equal to 1, and for this one, log base 6 of 6 is equal to 1. So they're giving me one more, actually they're not. I know one more hint, okay? So taking a look at number 12 here, I'm thinking about 81. I don't know much about 81, but I do know that 81 is going to be 9 to the negative second. Now let me look. Oh, look at that. There it is right there. That's all I need. So negative 2 times log base 4 of 9, which is x. So it's negative 2x. Bam, done. Next one, I'm thinking about 96. I don't know anything about 96. 1 over 96. Well, that's log base 6 of 96 to the negative first power, right? 90. Let's roll the negative 1. That's going to be log base 6. 96. That's what, 6 times 16. So 6 times 4 squared. Let's see. Do they have that? Well, they got the 6. There we go. Got the 6. Got the 4. Bam. I'm good as gold. So I've got negative 1 times the quantity log base 6 of 6 plus log base 6 of 4 squared. All right, I'm going to go ahead and I'm going to take that 2 and I'm going to swirl that 2 to right here. Okay, so I have negative 1 times the quantity log base 6 of 6 is 1 plus 2 times log base 6 of 4 is P. And I just have to add my negative signs and I'm done this whole problem. So it's negative 1 minus 2P. Okay, and there's the answer. All right, friends, so there we have gone through all 13 problems on this review of Fun with Logs on 5.3 to 5.5.